Now here is some help with your actual investigation and some very specific instructions for your investigation. You've logged onto the Focus e-learning software, the online portal, and now you go onto the Science Investigations 1. You click on here and it should take you to this place here. Now you scroll down on the left and you're interested in heating effect of a current. This is the experiment you choose. Now you see you have an introduction, design, etc. You're interested in the experiment, so we go for that straight away. Now here you see there's some water, and this water is being heated by some resistor that's immersed into the water. That is pretty similar to what you have in your kettle. And what you can change here is the voltage and the current as well. So what we want is to give it a full whack and turn the voltage to the maximum. You remember power is current times voltage, so if I have the highest possible voltage, that will give me the most power. What we're going to change in this experiment is the time. What we're going to keep constant is basically everything else. One thing that is important is we don't want to heat the environment, but we want to heat just the water, and therefore you press on to this insulation button. If you do that, then your results will be significantly better. The resistance of this resistor here in the water we will keep the same, and the mass of the water as well. If you want to, you can change that a bit to whatever value you choose. So for example 60 gram, or stick to the 50 gram as you like. This is down to you. Now we're going to start the experiment, and you need to record your initial temperature. So here is a zoomed in reading basically of the scale of my thermometer, and you see it shows me 20 degrees Celsius. So I want to go up in steps, say of maybe 30 seconds. See what works and whether you get any meaningful results. So here I have an increase in temperature in 2.5 degrees Celsius. That is probably a bit on the low side, so I'll just go for steps of 1 minute. That seems to be more feasible. So here I have something like 5.5 degrees Celsius more than I had before, so 25.5-ish is my final temperature. So you're going to record in your result your initial temperature, your final temperature, and then you're going to work out what the difference in the temperature is. You're going to plot the difference in the temperature against the time. So for 1 minute I have this final temperature here of 25.5 degrees Celsius. I need, as usual, 5 different data points. So now you go up here, well, you can try to drag that. I'm quite close to 2 minutes. There we go, 2 minutes, and I'm getting 31 degrees Celsius. Now you do the whole thing again for 3 minutes, etc., etc. And the important thing is that you then finally plot the temperature difference against the time. And remember to run through this 3 times, so you have 3 trials. And how you're going to get the specific heat capacity from that, you will see in the next part of the clip. So now you've collected your data and you've got a graph that looks pretty much like this. You have your time on here and you have your change in temperature here. The time will probably be in seconds, and say the change in temperature was in Kelvin. And you have some data points here, and this is more or less what it looks like. And you have drawn your line of best fit with Logger Pro automatically, so this is what you got. Now what you want to do is find the specific heat capacity of the water from this graph. So what you need to do is have a look at the formulae. Now what you have is you've measured the current, you've measured the voltage, and you have also measured the time, you have measured the change in temperature. And what we're after is the specific heat capacity of water. Now if we look back at the formula that we had, C is equal to Q over M delta T. That means to find C, now I need to see how I can actually get the gradient from this graph to give me C. Well, C is equal to Q over M delta T. Q is the energy. As we learned last year, the power is equal to energy over time. So I can therefore say that the energy is power times time. That applies here as well. So Q is also equal to power times time. Now the power is equal to, we'll do that in a moment, M delta T. So the power is equal to VI. So I have VI T over M delta T. This is the inverse of the gradient. All these other values are now given. And this is the inverse of the gradient. So I can actually find my gradient. So I would do that with the biggest possible triangle here. Say I got this, and I got some value, for example 300 here, and I got 500 for this. So 300 from here till here. Then my gradient would be equal to 300 over 500, so that would be equal to 3/5, and that is 0.6. So if I want to find, and that would be equal to delta T over T. Now in this case I'm interested in T over delta T, so I just do 1 over 0.6, and with that result I get 5 over 3, so that is approximately 1.7. So all I need to do is put whatever value you get here, and you might get something very different to this gradient. Put that value in here. The rest, the voltage, the current, and the mass, you had as control variables, so you can just check your settings in your experiment to find whatever gradient you get here. Hope this helps, and good luck with your investigation.